If you were to take Mount Everest and place it into the deepest part of the ocean, its peak would still be covered by over 2 kilometers of water. That is the sheer scale of the abyss we are talking about today. But depth isn't the only terrifying metric here. Down there, the weight of the ocean above you exerts a pressure of over 1,000 atmospheres. To put that into perspective, it is the equivalent of having an elephant stand on your thumb or a fully loaded semi-truck parked on your big toe. For decades, the consensus among the world's brightest minds was absolute. Nothing could survive there. They believed that at these depths, calcium would dissolve, proteins would warp, and life would be crushed into oblivion. It was assumed to be a dead, silent wasteland, a scar on the planet where biology simply stopped working. They were wrong. We are going to descend into the Mariana Trench, specifically to the Challenger Deep, the deepest known point on Earth. We are going to explore how this massive geologic scar formed, how we managed to reach the bottom, and most importantly, we are going to look at the impossible creatures that call this hellscape home. Because what we found in the dark didn't just change our map of the ocean, it rewrote the rules of life itself. To truly understand the isolation of the Challenger Deep, you have to understand the journey to get there. It is not just a long swim, it is a passage through entirely different worlds. When you slip beneath the waves, you start in the epipelagic zone. This is the sunlit surface layer, the top 200 meters. This is the ocean we know, the realm of blue water, coral reefs, sharks, and whales. Almost all marine life that we are familiar with lives here, because this is where photosynthesis happens. The sun fuels the food chain. But as you sink past 200 meters, the sun begins to fade. You enter the twilight zone. Here, the water turns a deep, bruising purple. The creatures here have massive eyes, evolved to catch the faintest glimmers of light. And many begin to use bioluminescence, creating their own light to hunt or hide in the gloom. Deeper still, past 1,000 meters, you are now in the midnight zone. Sunlight is gone. The water is pitch black and near freezing. The pressure is building, but we aren't even close to the bottom yet. You have to keep falling, past the abyss, past the continental rise, until you reach 6,000 meters. You have now entered the Hadal Zone. Named after Hades, the underworld of Greek mythology, this zone exists only in the deepest trenches of the planet. It is a world of crushing pressure, freezing temperatures, and total darkness. It is here, at nearly 11 kilometers down, that we find the Challenger Deep. How does a hole this deep even exist? The Earth is not a static rock. It is a dynamic, violent engine. The Mariana Trench is the result of a planetary collision that has been happening in slow motion for millions of years. It is formed by the process of subduction. The massive Pacific Plate, a gigantic slab of the Earth's crust, is crashing into the smaller Mariana Plate. But they don't just crumple up like mountains. The Pacific Plate is older and colder, making it denser. So as they collide, it is forced downward, sliding beneath the Mariana Plate and plunging deep into the Earth's burning mantle. This motion drags the seabed down with it, creating a V-shaped gorge in the ocean floor, a trench. This violence is also why the region is so dangerous. This is the ring of fire. The friction of the diving plate melts rock and creates magma, fueling the volcanoes that line the Pacific Rim and triggering massive earthquakes. The Mariana Trench isn't just a hole. It is a wound in the Earth's crust that is constantly being torn open. For a long time, we could only guess what was down there. We assumed it was a flat, mud-covered desert. The turning point came in 1960. In an era obsessed with the space race, a different kind of exploration was happening, one directed downward. Swiss oceanographer Jacques Piccard and US Navy Lieutenant Don Walsh climbed inside a bathyscaphe called the Trieste. It wasn't a submarine in the modern sense. It was essentially a tiny steel sphere hanging underneath a giant tank of gasoline used for buoyancy. As they descended, they heard a loud crack. The outer window of their entry tunnel had fractured under the immense pressure. They were kilometers down, completely alone, in a vessel that was literally groaning under the weight of the ocean. Most would have aborted. They decided to keep going. When they finally landed on the bottom, kicking up a cloud of silt, they looked out of their tiny, thick viewport. They expected emptiness. Instead, in the beam of their spotlight, they saw a flatfish, a living, breathing vertebrate, casually swimming along the bottom of the world. That single moment shattered our understanding of biology. If life could exist here under 1,000 atmospheres of pressure, then life was far more resilient than we had ever dared to imagine. So how does life survive where the conditions should kill it? In the absence of sunlight, the creatures of the Hadal Zone have had to find a new energy source. Photosynthesis is impossible here. Instead, this ecosystem relies on chemosynthesis. Life here is powered by chemicals. Some of these creatures feed on the minerals released by volcanic vents, superheated geysers of water shooting up from the seafloor. Others rely on what scientists call marine snow, a constant, gentle rain of organic debris, dead plankton, and fecal matter sinking from the productive surface miles above. It is a scavenger's world. The animals here are true aliens. We have found amphipods, shrimp-like crustaceans, that grow to massive sizes, far larger than their shallow water cousins, a phenomenon known as deep-sea gigantism. We have found the snailfish, the deepest living fish ever discovered. It looks like a ghostly, translucent tadpole. It has no scales, and its bones are soft and cartilaginous, so they don't snap under the pressure. Then there are the xenophyophores. These are single-celled organisms, similar to amoebas, but in the trench, they grow to the size of a grapefruit. They are delicate, fragile giants that filter the water for food, highly adapted to an environment that destroys anything rigid. They survive because they have evolved cellular structures that bind water molecules tightly to their proteins, preventing the crushing pressure from warping their bodies. They are perfectly adapted to a world that would instantly kill us. And yet, despite the fact that the deep ocean covers more than half of our planet, it remains one of Earth's least explored regions. We have better maps of the surface of Mars than we do of our own ocean floor. Since 1960, fewer than 30 people have ever visited the Challenger Deep. We have sent 12 people to walk on the moon, but only a handful have seen the bottom of our own world. Much of what we know doesn't come from human eyes, but from robotic probes and unmanned landers, or worse, from damaged specimens brought violently to the surface in trawler nets, exploding as the pressure drops, arriving on deck as unrecognizable gelatinous blobs. This leaves huge gaps in our understanding. We have identified only about 400 species in the Hadal Zone. Scientists estimate there are thousands more waiting to be found. Every time we go back, we find something new. New species, new geological formations, new chemical compounds that could revolutionize medicine or industry. The Mariana Trench teaches us a humbling lesson. We often look to the stars to find alien life, searching for habitable zones on distant exoplanets. But we have an alien world right here, a world of darkness, crushing power, and mysterious life that thrives against all odds. It is a reminder that life is stubborn. It finds a way to exist in the margins, in the extremes. But the deep ocean is not just a curiosity, it is a critical part of our planetary system, cycling, carbon, and heat, and we barely understand how it works. There are mysteries down there in the dark that are waiting to be solved. And perhaps the most exciting part is realizing how much we still have left to discover. If you want to join us as we continue to explore the unknown corners of history, science, and the natural world, make sure you are subscribed. The world is deeper than you think, and we have only just scratched the surface.